go. We are going to try to finish up section 4 today. All right, just on these transformations of the sine and cosine functions. So in this example, they have given you let f of x equal 6 cosine x. So obviously it's not just the cosine function, it's 6 times the cosine function. So it's a transformation of the cosine curve. So what I would like to do is let's graph it, and then we can use the graph, and I'm going to show you the algebra technique to answer these questions, so you'll have two options. And then obviously the graphing calculator could do anything we ever wanted it to do. I'm trying to get you to not use it, because if they ask for exact answers, technically the graphing calculator is going to give you the decimal answer of all this, not the exact answer. All right, so here we go. If we're going to graph it, let's establish, guys, the original cosine graph, right? And I always like to have my unit circle handy for these, because that's how I graph it, using my quadrantals. All right, the original cosine function, what were his key points that lived on his graph? The original cosine graph, well, at 0 radians, the ratio was 1, right? The cosine of 0 radians. Then we had pi over 2. At pi over 2, the ratio was 0, right? The x-coordinate represents the cosine of an angle on the unit circle. Then we have pi. At pi radians, the ratio was -1. And then at 3 pi over 2, my third 90-degree angle, my ratio was 0. And then I'm all the way back to where I started. I'm at 2 pi radians this time, though. I have made one complete trip around, and my ratio is back to 1. And then everything would start repeating again, right? Well, the original amplitude was 1, right? It went 1 unit up and 1 unit down from that midline. Well, the new amplitude, though, it's going to be different, considering this is a transformed function. And then the original period, how many units did it take for us to make one complete cosine curve? 2 pi radians. All right, let's see what they want us to do. Guys, the only change to this function is the 6 on the outside. So who is that 6 changing? Is it changing the x-coordinates that live on the inside, or is it changing the y-coordinates that live on the outside? It's changing y. We're going to make our y-coordinates 6 times as big. So all we have to do is times our y by 6, and we'll have our new curve. All right, guys, can I also go back to one thing? I was trying to train you guys for the future. Once you know your period, right, you divide that by 4 into those sub-intervals, and then that will get you your counting increment. All right, I'm going to do that in a second, just to remind you. All right, so here we go. This ordered pair is now going to be 0 times 6, 1 times 6 is 6. So now we're living it up. Guys, give me a favor. Cut these in half so we have enough lines. I meant to do that, and I forgot. All right, so now we're living up here at 0, 6. All right, times your y-coordinate by 6, and we are at pi over 2, 0 still. So pi over 2 and 0. And then 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, and 8 pi over 2. Negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2, and negative 4 pi over 2. All right, then we go here. Pi, we times our y-coordinate by 6. Now we're down there at negative 6. So pi, negative 6. 3 pi over 2 stays the same. 0 times 6 is 0. 2 pi stays the same. 1 times 6 is 6. So there it is, guys. There's one period or one cycle of our transformed cosine curve. All right, there's our seagull. And now everything else would repeat. So now I'm up at 1, I'm up at 6, right? So then I'm at 0. Then I'm at negative 6. Then I'm back to 0. And then I'm back up at 6. And we can even work it backwards, right? If I'm up here, the next one would be at 0. The next one would be at negative 6. Oh, I'm way off. The next one would be up at 0 again, and then the next one will be back up at 6. So there's a bunch of cycles, well, really 3, of your cosine curve. and then it would just obviously keep on going. Okay? My amplitude is now 6 times bigger. I went 6 up and 6 down from that midline. My amplitude, my new amp, is now 6. My period is still the same. I did nothing to affect my x values. And again, if you take 2 pi and you cut it into fourths, you divide it by 4, your counting increment is still that 1 pi over 2. You're still counting by 1 pi over 2 to get to each of your key points. All right, here we go. Now that you are looking at the graph, guys, these questions should take 3 seconds for you to answer. However, I would like to show you an algebraic approach as well in case you don't have a graph to look at. All right, so looking at the graph, it says, what is the y-intercept of the graph of f? Guys, who's the y-intercept? What y value? It's 6. It's totally 6. However, algebraically, how do you find a y-intercept? X has to be 0, right? So you find f of 0. So if I found f of 0, guys, that would be 6 times the cosine of 0 radians. You're plugging an angle in, and a ratio is going to come out. So at 0 radians, what is your cosine ratio? What is the cosine of 0? Well, guys, the cosine at 0 radians was what ratio? It was 1. So that's literally 6 times 1, which is 6. So you can still find the y-intercepts algebraically by plugging a 0 in. All right, for what numbers, x, where x has to be in between negative pi and pi. So guys, you're literally looking at negative pi to pi. X has to be a number in between them. You're looking at this section of the curve. Where is it? The graph of f increasing. So guys, if we are looking from here to here, the graph is going up and then it's coming down. So from a left to right, as x got bigger, y got bigger, but now as x gets bigger, y is getting smaller. So on what interval of x is this function increasing from negative pi to pi? Guys, it's increasing from negative pi all the way to an x value of who? 0. So from negative pi to 0, this is an increasing function. So all you have to say on the interval from negative pi to 0, it is an increasing function. You just give the interval of x values. And there's no algebra involved in that. You have to be looking at a graph to see where it's increasing and decreasing. All right. What is the absolute maximum value of f? Guys, look at this graph. What is the highest value this function is ever going to reach? 6. Right? Because we know it's going to repeat. It's not like there's a section of it where it's going to get bigger. That's going to do this for the rest of its life. All right, here it says, for what numbers x, where x has to be in between negative 2 pi and 2 pi. So now we're looking from negative 2 pi to 2 pi. You're looking at these two cosine curves, basically. For what numbers x does f of x equal 6? Well, guys, look at the graph. From negative 2 pi to 2 pi. We're looking for f of x to equal 6. Do you agree? On this interval, if you can even see, I'm sorry, at home, that it's going to equal 6, 1, 2, 3 times, yes? And it happens at what x values? It happens at negative 2 pi, it happens at 0, and it happens at 2 pi. So the x values that make this equation true are definitely x equals negative 2 pi, 0, and 2 pi. Those are definitely the answers to this question. Okay, now notice, in this interval, they let you include both the negative 2 pi and the 2 pi. In the next interval, they stopped including negative 2 pi. It's right up onto him, but not including that x value. So pay attention to who's included and who's not. All right, let's say we want to answer this by ourselves. Guys, when does f of x equal 6? Take your function, 6 cosine x, and set it equal to 6. When does 6 cosine x equal 6? So get cosine x by itself, divide both sides by 6, and you get cosine x equals 1. So normally, guys, if you remember from Algebra 2, when you know the ratio but not the angle, you would use the inverse cosine to figure out who the angle was, right? That's the inverse cosine's job, is to find an angle. However, it is limited. We haven't done the inverses yet, so let's try to figure this out without the inverse cosine. Guys, can you remember the cosine of what special angle had a ratio of 1? Guys, on the unit circle, who had an x coordinate of 1? Only which angle? 0, but also who lands in that same spot? 2 pi, and so did negative 2 pi. So you could have algebraically reasoned this out by going and figuring out the cosine of what special angles in between negative 2 pi and 2 pi had a ratio of 1. Guys, the only angles that have a ratio of 1 are angles that land where 0 radians land. So it would be 0, 2 pi, and negative 2 pi, even if you solved it algebraically. Okay, let's go to the next question. For what numbers x, where x is in between negative 2 pi and 2 pi, but guys, this time, now they're not going to let you include negative 2 pi as a solution. You can go right up into them, but not include them. Does f of x equal negative 6? Well, guys, look at it. Negative 2 pi to 2 pi. Do you agree that it equals negative 6, 1, 2 times in that interval? Absolutely. It happens at an x value of negative pi, and it happens at the x value of pi. So we know the answer to this question is negative pi and pi, just by looking at the graph. Algebraically, you could say, okay, when does 6 cosine x equal negative 6? Divide both sides by 6. We need the cosine of x to equal negative 1. So guys, the cosine of what special angle had a ratio of negative 1? Guys, go to your unit circle. Only what angle had an x-coordinate of negative 1 on the entire unit circle? Pi. So pi would make this equation true, or negative pi is also in that interval from negative 2 pi to 2 pi. So you would also get x equals pi and negative pi as your two answers. All right, next one says, for what numbers of x, where x is a number in between negative 2 pi, but not including it, to 2 pi. So we're still looking on this interval, these two cosine curves. Where does f of x equal negative 3? All right, this is a problem. Guys, just look, let's reason it out. From negative 2 pi to 2 pi, here's negative 3. Do you agree? There's a point here that has a y-coordinate of negative 3, but I don't know what x value that is. I know it's in between pi over 2 and pi. So guys, I know it's a quadrant 2 angle. There is a quadrant 2 angle that makes this true. All right, there's another y value of negative 3 on my graph in this interval right there. But I don't know what angle that is. But I definitely know it's in between pi and 3 pi over 2. That is a quadrant 3 angle. There's definitely a quadrant 3 angle that's going to make this equation true. All right, same thing, guys. They said we could go from negative 2 pi to 2 pi. So now I have this cosine curve that's going to have answers on it. So again, negative 3. There's another angle that has a y-coordinate of negative 3, that has a ratio of negative 3. I don't know what angle that is, though. I know it's between negative pi over 2 and negative pi. Guys, that's quadrant 3, right? When you rotate counter or clockwise now, regular clockwise. There's another angle right here that produces a ratio of negative 3. But I don't know what angle that is. But I know it's between negative pi and negative 3 pi over 2. That's quadrant 2. So that means there are 4 answers to this equation. 2 angles live in quadrant 2. One is positive, one is negative. And 2 angles live in quadrant 3. One is positive and one is negative. All right, what angles are they? So let's do this a little bit algebraically then. When does 6 cosine x equal negative 3? Divide by 6. Okay. They're asking you the cosine of what angles in between negative 2 pi and 2 pi have a ratio of negative 1/2. Well, guys, bells, whistles, and sirens should be going off inside of your head. Negative 1/2 is one of your special ratios for one of your special angles. 30, 60, 45. That's one of your special ratios. Guys, if this was like negative 1/7, that is totally a calculator question. I would not be able to answer that and know what angle had a ratio of 1/7. But 1/2 is special. So guys, can you picture your special right triangle if you don't have it memorized? Which angle? 30 or 60? Because I know my 45 was like all the cosines were root 2 over 2 and sines were root 2 over 2. My tangents were 1. I know it's got to be a 30 or a 60 reference angle. Who had a cosine ratio of 1/2, 30 or 60? We know we're working with the 60, right? Which is a pi over, in radians, 60 is pi over 3. So we know we're playing with a pi over 3 reference angle, right? So I know that the cosine of some multiple of pi over 3 is the answer to this question. It's definitely a 60. All right, so guys, now we play the game. All students take calculus. What two quadrants was the cosine ratio negative in? All students take calculus. So all in calculus means that cosine was positive in 1 and 4, but it's negative in 2 and 3. So guys, there is an angle that answers this in quadrant 2 with a reference angle of pi over 3. And there is an answer to this in quadrant 3 with a reference angle of pi over 3. Now you just got to figure out, what multiples of pi over 3 are these? Guys, use your anchors. Who lives at pi? How many pi's over 3 live at pi? Anybody know? 3 pi. Yeah, Mackenzie. So that means the one before it was how many pi's over 3? If this is 3 pi over 3, 1 pi over 3 before it would have been 2 pi over 3. Guys, that's an answer. 2 pi over 3 is an angle that's going to make this true. All right, well, if this is 3 pi over 3 with a reference angle of pi over 3 in quadrant 3, who's the angle right after it? If this is 3 pi's over 3, this is 4 pi over 3. 4 pi over 3 makes this equation true. Okay, so those are our two positive angles. That's 2 pi over 3. That's 4 pi over 3. Now you got to do it in the negative. So guys, just think of this. This is negative pi, right? Because we know we're in quadrant 3 and 4 with our answer still. So here's negative 3 pi over 3. So the one before it is negative 2 pi over 3. And the one after it is negative 4 pi over 3. So it's the same angles, but now you have their positive and negative versions. So the 4 angles that make this true, here is your negative 2 pi over 3 and your negative 4 pi over 3. The 4 angles that make this true are 2 pi over 3. I guess you could put plus or minus to make it an easier, shorter list. And then plus or minus 4 pi over 3. And they do. They expect you to be able to reason that out with your special angles without a calculator. Because if you ask the calculator, it gives you the decimal versions of what 2 times pi divided by 3 is. And then you'd have to figure out, all right, well, who is that? Was that 2 pi over 3, 4 pi over 3? Or was it a pi over 6? You have to figure, we should know by our special angles. All right, and then it says, what are the x-intercepts of f? Guys, it has an x-intercept where? Infinitely many. 1 pi over 2, 3 pi over 2, 5 pi over 2. Odd integer multiples of pi over 2. Yes?
I can't quite agree with next to the 3 pi over 3 in that little grid.
Pi over 3. They have reference angles of pi's over 3.
Oh, both of them. Okay.
Once you know who your special angle is, that's your reference angle. Now you just got to figure out what version of that pi over 3 landed in each quadrant.
Oh, it was just very tiny.
Yeah, I know. I'm sorry. I'm trying to squeeze stuff in. Yep. All right. So, guys, we would say the x-intercepts are pi over 2 plus or minus. Each one is pi radians away times k revolutions. Or, like I said, they are described as odd integer multiples of pi over 2. All right. All right, how do we feel about that? Is everybody okay? All right, I don't know what's going on, but there are so many cameras. I'm looking at like black squares. I don't know. I've had tech issues since yesterday. I hope that's not how many cameras are off. That's not good. All right, let's go down to the bottom. This is the only other type of question, I believe, is on your homework. Guys, your homework is 3 questions. It's really, really short. All right, so let's look at the last question. And the last questions is, guys, finding the average rate of change. It's slope. These are literally change in y over change in x questions. Just good old slope. But remember, a straight line has a constant slope, right? It has the same rate of change in between each pair of points. That's what keeps it straight. Clearly, these cosine and sine waves do not have the same rate of change over the entire life of their graph. However, you can find an average rate of change on a specific interval of x values. So guys, they said, take the function f of x equals cosine x, something that does not have a constant rate of change. Find the rate of change on the interval when x is 0 to 4 pi over, is that 3? I can't read it up here. Is it 3? Yeah. Okay, so you're finding the average rate of change from when x is 0 to when x is 4 pi over 3. Because at the end of the day, if you're going to find change in y over change in x, you need points. You need ordered pairs to subtract. So we need to create points. So first we're going to plug 0 in, create an ordered pair. 0 went in, what y value came out? Then we're going to plug in 4 pi over 3. 4 pi over 3 went in, what ratio came out? And we'll create ordered pairs to do change in y over change in x. And guys, I'll be the first to admit, these slopes ain't going to be pretty. We're going to be dealing with pi's and radicals. It's just, this is what it is. But at the end of the day, it's change in y over change in x. All right, so f of 0 is going to be the cosine of 0 radians. Plug 0 in, what ratio comes out? Guys, at 0 radians, right there, that was the ordered pair 1, 0. The cosine of that angle is the x-coordinate, which is 1. So now I know when 0 went in, a ratio of 1 came out. We got a point. Nice and easy. I don't know if there's an easier point to work with. All right, now let's plug in 4 pi over 3. F of 4 pi over 3. Now we have to take the cosine of 4 pi over 3. All right, well, guys, first one, you have to find your reference angle and what quadrant are you in. Where do 4 pi's over 3 live? Well, this is where 3 pi's over 3 live, and this is where 6 pi's over 3 live, right? That's pi, and that's 2 pi. So where does 4 pi 3 over live? Does it live in quadrant 1, 2, 3, or 4? It lives in quadrant 4. Oh, sorry, my God, Mackenzie, 3. You're right. All right, so there is 4 pi over 3. So basically, when you take the cosine of 4 pi over 3, you are taking a reference angle of 1 pi over 3. You are taking the cosine of pi over 3, but you are in quadrant 3. So that'll affect the positive or negative sign. Guys, what's the cosine of pi over 3? What's the cosine of a 60? We just did it. Yeah, who said it, Case? Yeah, cosine 60 is 1/2, so we know it's 1/2. However, all students take, what is the cosine ratio of an angle in quadrant 3? It's negative, because the x-coordinate would be negative, so it's negative 1/2. So now you know that when 4 pi over 3 went in, a ratio of negative 1/2 came out. And now you have 2 points, they ain't pretty, to find slope with. All right, let's do change in y over change in x. So I'm going to do negative 1/2 minus 1 over 4 pi over 3 minus 0. All right, guys, negative 1/2 minus 1 more, it's negative 1/2, it's negative 3/2. If you half, make that 2 over 2, right? So it's negative 1 subtract 2. That's negative 3 over a common denominator of 2. Divided by 4 pi over 3 minus 0, we got really lucky. It's 4 pi over 3. All right, but now we have a complex fraction. We have fractions within a fraction. Multiply by the reciprocal of your denominator. And you're going to get negative 9 over 8 pi. And you're done. And that's your slope. It's not pretty, it ain't great, but it is change in y over change in x. How do you guys feel? Everybody all right? So again, it really goes along with how well can you plug an angle into a trig function and get that special ratio out. All right? All right. What do we have? Let's do it. Let's do it. We got time. What would class be with if I wasn't teaching to the bell, guys? I need space. I'll go up here. All right, so they've given us. Now we're going to find the average rate of change from pi to 3 pi over 2. All right, so let's plug it in. First, we're going to plug in pi to create an ordered pair. So f of pi is going to be the sine of pi, but then you divide it by 2. So really, it's not the sine of pi anymore. It's the sine of pi over 2. Well, guys, at pi over 2, what was the y coordinate? So it's 1. All right, so that means pi went in and 1 came out. There's a point. All right, now we have to plug in 3 pi over 2. F of 3 pi over 2. It's going to be the sine of 3 pi over 2, but then divided by 2. Now, guys, isn't dividing by 2 the same thing as timesing by a half? So instead of dividing by 2, just to make my life easier, times by a half, and what angle is that really going to be? 3 pi over 4. It's the sine of 3 pi over 4. All right, we got to figure out what ratio that was. Well, guys, a 45/90 was 1 to root 2. All right, but what quadrant are you in? Guys, in the world of pi's over 4, here's 4 pi over 4, and here's 8 pi over 4. Pi and 2 pi. Where's 3 pi over 4? In what quadrant? Quadrant 2, with a reference angle of 1 pi over 4. So the sine of 3 pi over 4 is just like taking the sine of pi over 4, but you're in quadrant 2. So guys, what's the sine of pi over 4? Sine of 45 is 1 over root 2, which was root 2 over 2. And what sign is the sine ratio in quadrant 2? All students. It's, nobody knows? No, all students. It's a positive y, left and up, right? So it's positive. So all students tell you that sine is positive. So it's a positive root 2 over 2. So now 3 pi over 4 went in, and root 2 over 2 came out. There's your points. Now we find our change in y over change in x. All right, I'm going to do root 2 over 2 minus 1 over 3 pi over 4 minus 1 pi over 4. I'm sorry, minus pi. Okay. Get a common denominator, that's 2 over 2. So you get root 2 minus 2 all over 2 divided by, this is really what? Pi over 1 becomes 4 pi's over 4. So that's going to be, what, negative 1 pi over 4? Everybody okay? And then we just multiply by the reciprocal. I'm running out of room here. I'm going to give my negative to the top, though. It just makes me feel better. So I'm going to get negative 2 is going to be negative 2 root 2 minus or plus 4 over pi. Are you okay? All right, so average rate of change. Just plug your points in, create points. It seems to me the hardest part is you guys working and finding your special ratios. All right? All right, let me just double check the attendance and you guys will be good to go. Guys, your homework tonight is 3 questions. It is so short. Just trying to give you guys a couple examples to practice. You're good to go, guys. Thank you.